Hi there, this is Miss Page, and today we are going to be talking about how we can sketch the graph of a quadratic function or parabola using only the vertex point and the zeros where the function intersects the x-axis. So in these problems we will be using only 3 points, all right, to get a decent sketch. We won't be using all of our knowledge about transformations. So we're going to find the zeros algebraically, and we're going to use our factoring skills from a previous lesson that we have been working on. And so this is the procedure here for figuring out or solving for our zeros using algebra. First thing we're going to do is let our function be equal to 0, and here is why. Zeros, remember, by definition are x values, so values of x, specifically when y equals 0, because this would put those points on the x-axis. And the function, remember, like f of x, represents the y variable. So we let the function, or what represents y, be equal to 0. And now when we solve for x, those x's create a y of 0, making them the zeros of the function. So in these problems, we will expect our polynomials to factor. So we will factor completely what we have on one side. And we're going to use what we call the zero product property. So let's talk about that here real quick. So down here we can see the zero product property. This is also in your notes. This is huge for when we use factoring to solve things, because when we factor, we create a product of factors that equals 0 in these problems. So we know that a times b equals 0. Well, in order to get an answer of 0, then either the a value has to be equal to 0 or the b value has to be equal to 0. So this is going to allow us to continue to solve for x, because a will be one of our factors, b will be another of our factors involving x, and then we can use basic algebra to solve for the zeros and make our conclusion. All right, let me show you how this is going to work in a problem. Oh, well, one other thing. This information is also prior knowledge. So remember our standard form structure and how we identify A, B, and C. And we have learned that we can calculate the coordinates of our vertex, our h and our k, that our h is going to be -1 times b divided by 2 times a. And then we can find k by plugging in the number for h to our function for x, doing the math using our order of operations, and that then gives us k. All right, so here in our first example, we are going to find the zeros algebraically. So we've done some work where we find them like using the graph, but that we're not allowed to do here. We have to use our algebra. So this part, the work must be shown. We are going to state the vertex and whether it's a maximum or minimum. We'll need to do some work there too, because this is our standard form. We'll have to calculate h and k. And then once we have our zeros and our vertex information, we will graph the function using those 3 points. All right, so let's go to part A, which is our zeros. So our zeros are values of x when our function or y value is 0. So we start by letting f of x be 0, and that becomes then equal to our 2x squared minus 4x minus 6. So now we're going to factor this trinomial completely. We should see we have a GCF of 2. So we're going to get 0 equals 2, and that will be times a new trinomial of x squared minus 2x minus 3. And then we should factor our trinomial into 2 binomials. So now we have 0 equals 2 times the binomials, and our binomials will be x minus 3 and x plus 1. We can check that using our distributive property. X times x is x squared. This is negative 3x plus 1x, which is negative 2x. and negative 3 times 1 is negative 3. So now what we're going to do is use the zero product property. The zero product property says if the product of these factors equals 0, at least one of them has to be equal to 0. Now the factor of 2 doesn't involve the variable of x, so there's no way for 2 to be equal to 0. So 2 can't be 0, so we're going to ignore that one. But the other two involve x, so it's possible x minus 3 can be 0, and it's also possible that x plus 1 can be 0. And so using our algebra, here we would add 3 to both sides. So this gives us x equals 3. And here we'd subtract 1, giving us x equals negative 1. The 3 and the negative 1 are the zeros of our function. So our zeros are negative 1 and 3. Alright, so that completes part A. So now we're going to take a look at part B, which is to state the vertex and whether it's a maximum or minimum. So our vertex, we have to calculate h. So our h, remember, is negative 1 times b divided by 2 times a. So back up here, we've learned that the coefficient of x squared is a, so a is 2. That the coefficient of x is b, so b is negative 4. And our constant here at the end is our c, so c is negative 6. So what I'm looking for now is plugging in my numbers. So negative 1 times b will be negative 1 times negative 4. And then 2 times a becomes 2 times 2. So negative 1 times negative 4 would be positive 4. 2 times 2 would be 4. And 4 divided by 4 would be 1. So our vertex, the x-coordinate, is 1. Alright, so now we need k. So now I'm looking at k. Remember, is we want to take our 1 and plug it into our function, our f of x. So it's f of 1. And this is going to give us 2 times 1 squared minus 4 times 1 minus 6. So 2 times 1 squared minus 4 times 1 minus 6. Now we want to use order of operations to simplify this. So we have 1 squared, which is 1. So this is 2 times 1, which is 2. Minus 4 times 1, which is 4. So 2 minus 4, minus 6. Now we have to go left to right. So 2 minus 4 would be 2 plus negative 4. It would be negative 2. And then this would be like plus negative 6. So that's going to give us negative 8. So that is our k value. So our vertex here is 1, negative 8. And that would be then a minimum in this case because our a is positive. So we do not have any kind of reflection, any x-axis reflection. So this is a minimum. And that finishes that part B. Alright, so now we're going to graph just using our zeros and our vertex. So we have to get down to negative 8 is pretty much what I need to do here. So I'm going to put my x-axis right here. And since our zeros are at negative 1 and 3, not a big deal there. Just got to make sure that we draw our y-axis so we can get to both of those numbers. So this would be negative 1, this is 1, and this is 3. And then we have the y's, negative 2, negative 4, negative 6, and negative 8 here. So our zeros are at negative 1 and positive 3. And then our vertex is at 1, negative 8. Now here's something I want you to keep in mind. Remember, your vertex should be on the line that's exactly halfway between those two zeros. So if it's not, if it's off center, something's wrong with at least one of these points. So now we know it's U-shaped, so we're still going to draw it U-shaped, but we're not going to add any more points to this. So we're just going to do a sketch here as best we can, drawing it as a U shape, getting that end behavior in there. It's not very good either. There, nope. Okay, I'm going to come down this way. And that finishes up the graph. So that's our part C in this case. All right, let's take a look at this problem. So this one, the structure, we have g of x equals negative x squared minus 3x. This is our standard form. We've talked about if we have a linear term, an x term, as well as an x squared term, then we know we're in standard form, not vertex form. And so what I'm going to do here is find my zeros algebraically. So again, zeros are values of x that create a function or y value of 0. So g of x is our y, so we get 0 equals. This negative, remember, is negative 1. So I'm going to put that in there for emphasis. So I have negative 1x squared minus 3x. So now my GCF here is, because my first term here is negative, what I'm going to do is factor out a negative GCF, so negative 1, and then also x. So I have 0 equals negative 1x times. So this would be positive x. Negative 1x times x would be negative 1x squared, and this would have to be plus 3, because negative 1 times 3 is negative 3, and times x gives us the negative 3x. So this is just a GCF factoring. We only get one binomial in this case. So now we're going to use that zero product property concept. Which says that if the product of these two factors equals 0, at least one of them has to be 0. Now this time, your GCF of negative 1x can be equal to 0 because it involves x. So negative 1x can be equal to 0, and so can x plus 3. So be careful here. Remember, we're undoing multiplication in this structure. This means negative 1 times x. We're undoing the multiplication, so we divide both sides by negative 1. So this is going to give us x equals, and 0 divided by any other number is always 0. So it gives us x equals 0. Here we're going to subtract 3 from both sides, and that gives us x equals negative 3. So those are our zeros. Our zeros are at negative 3 and 0, which would be the origin point when we graph it. All right. So now, second part, we're going to figure out the coordinates of our vertex. All right, so for our vertex here, we are going to have to calculate h, which is negative 1 times b divided by 2 times a. All right, so back up here, our a would be negative 1, represented by that negative sign. Our b is the coefficient of x, so that's negative 3. And there's no constant added or subtracted, so we know that means c is 0. So for h, we have negative 1 times our b of negative 3 divided by 2 times our a of negative 1. So here we have negative 1 times negative 3, which would be positive 3. We have 2 times negative 1, which would be negative 2. All right, so now we've got a fraction here. Nothing we can do about this. We can leave it as negative 3/2. If you want to, you can write it as negative 1/2, which you don't have to if you don't want to. So the coordinate of our vertex is negative 3/2 or negative 1/2. Now, when we go to do the calculation for k, though, we need our improper fraction because we can't multiply with mixed numbers, if you recall. So k is going to be our function evaluated at our negative 3/2. So we get g of negative 3/2. So this is going to give us negative 1 times our negative 3/2 quantity squared, there, and then minus 3 times our negative 3/2. halves. All right, let's talk about this math. So this means negative 3 halves times negative 3 halves. So we multiply straight across, and that gives us positive 9 over 4. And that we need to multiply times negative 1. So now we have negative 1 times anything would be the opposite. So this is negative 9/4. Over here, I think it's probably best for us to look at this as a plus negative 3, which has a denominator of 1, times this negative 3 halves. So now, negative 3 times negative 3 is positive 9, over 1 times 2 is positive 2, and we have a plus positive 9 halves. Now there are a couple of different ways to go from here. If we leave them in fraction form, we need a common denominator. That common denominator would be, the lowest common denominator would be 4. And so this one is 4. To get a 4 here, we have to multiply top and bottom by 2. So now we have negative 9/4 plus 18 over 4. And then when we add our fractions, remember with the common denominator, the denominator stays the 4. And we add the negative 9 plus 18, which would be positive 9. So we have 9/4. And you don't have to write it as a mixed number, but you do have to know what mixed number it represents in order to graph it correctly. So we have to know that this would be 2 and 1/4. And again, the math there is division. 4 goes into 9 twice, so that's our whole number of 2. And our remainder of 1 over the 4 gives us the fractional part. So that gives us 2 1/4 if we want to write it as a mixed number for our vertex y coordinate, the k value. So now what we're looking at is going back up here to our function, and a was negative, so we do have a reflection across the x-axis, which means that this vertex must be a maximum. So now we're done with part B. These are kind of big problems. A lot going on in them, but a lot of important stuff. Alright, so now we're going to finish our graph, and we're only going to use these two zeros as 2 of our points and our vertex as a third point. So I've got negative 3 and 0. So maybe I'll put my y-axis here, and my y is up to 2 and 1/4, so not very high up. So this is 1, 2, 3, negative 1, there's my negative 3. So my zeros are at negative 3 and 0, which is my origin. And then remember this negative 3 halves is negative 1 1/2, so it would be halfway between negative 1 and negative 2 right here, and then up 2 1/4. 1, 2, and a little bit more for 1/4 of the way up. That's our vertex. And then I'm going to draw in my parabola, like so. All right. So we are going to stop this portion of the lesson here, and you will then be able to work on the graphing problems from the assignment. Tomorrow we are going to talk about the other types of problems. We're just going to do our algebra to find zeros, and then we'll finish everything up. All right? Have a good day for the rest of the day.